Okay.
It's dissolved in 100.0
100 point or 100.0?
100.0 milliliters of H2O. What will be the boiling temperature? What will the boiling temperature of the solution be?
Okay, so I want to know what the boiling temperature is going to be if I have this solution.
Right.
Okay. Now for boiling temperature increase and for freezing point decrease, the equation is the same. There's the change in temperature. That's not the new boiling point. That's the change in boiling point temperature. Okay, is equal to I, which is the Van Hoff factor, times K times M. All right, that's the same equation for boiling point increase and freezing point decrease. The only difference is if we're looking at boiling point, we're going to put a little b as a subscript here and here because those are the things that are kind of different. All right, so let's start looking at what these different factors are. First thing we're going to look for is the change in temperature. Now you need to know the original temperature for boiling for pure water is 100 degrees centigrade, right? All right, so we know that the boiling point for pure H2O at sea level, all right, is 100 degrees C. What we're going to do is find first the change in that boiling temperature. All right, so we need what I is. Well, if I've got calcium chloride as a solid and I put it in water, it's going to break apart into separate ions. Okay, and we're going to break it up then into calcium and chloride ions. And we got 2 chloride ions. Okay, so for this then, I equals 3. Okay, so we know that we're going to use 3 for that number right there. All right, we're going to multiply it times K sub B, which is a constant that you look up in your test references. And we showed that in class on Friday. And here is the short table that has the boiling point, freezing point constants, and the normal boiling temperatures right there. Well, here's water. Normal boiling temperature is 100 degrees C. And the K sub B is 0.512. So 0.512. And that is degrees C over molal.
There was another page in the handout that told us it was 0.515.
Okay. Well, if you use that, I'll accept that. That's fine. Okay. You know what page that's on?
No.
Page 29. That's a typo. I need to fix that. 512 is the standard number, I think.
You skipped it.
Go past it. How about that? Okay. So, nobody noticed that and sent me that by email. Too late.
Holy cow, that's because we thought that it was that. I didn't know which one was right.
Okay, that's okay. So, did anybody use 512? Because that's the one I referred to on Friday. All right. Everybody else used 515?
I didn't use 512.
All right. All right, so, and it said degrees C per molar, which puts molal on the bottom. Okay? And then we want to know what molality is. Okay. To find molality, we're going to have to do some calculations.
Right.
All right. So we need to know the molar mass for calcium chloride. Let's move down here at the bottom of this page and work on it down here. Let's see. Calcium and chlorine.
Yep.
And calcium's atomic mass is 40.078.
Yeah. We already did this.
Oh, we did that the other day?
Yeah.
All right, well, 35.453, and you do all the math, times 1, times 2, and what did we get? 110, so point what?
We got 984.
Okay, and I don't have to round anything off. That's grams of calcium chloride equals 1 mole of calcium chloride. Okay, good, we got that. So let's see, we're trying to find the molality, and molality is the moles of solute and the solute here is calcium chloride, over the kilograms of solvent, and the solvent is water.
Right.
All right. So we're trying to find the moles first. So we've got 0.37 grams of calcium chloride, and we're going to use this ratio down here, or this equality statement, to build a ratio to convert to moles. So we're going to put 110.984 grams of calcium chloride on the bottom, and 1 mole of calcium chloride on the top. And then we go about canceling units and species, trying to find my little red pen here. We did that on Friday too? OMG. Oh.
Tom, you would know, wouldn't you?
Okay.
It's a good refresher.
All right. So cancel grams and calcium chloride.
All depends if losses.
All right, and that's how we're going to find the moles. Okay. All right, and then we're going to, now we have 100 milliliters of water. Okay. We need to convert that into kilograms, because that's what we need on the bottom, kilograms of water. So we've got 100.0 milliliters of water. Okay, we've got to first convert that to grams, and the equality statement is 1 gram of H2O equals 1 milliliter, 1.00 milliliters of H2O. So I can convert that into grams using that equality statement, 1.00 milliliters H2O. Looks sloppy. I'm sorry. I'll try to slow down. 1.00 grams of H2O. That will get us to grams of H2O. And then we have we need to convert that into kilograms, and the ratio you need is that there are 1,000 grams in 1 kilogram. So 1,000 grams in 1 kilogram. Okay. And grams are going to cancel. And when we get done with this, we're going to have our amount of H2O in kilograms. Now the reason I did want to go through this in some detail here, because some of you on the last test failed to do this part. You had to convert from grams to kilograms on the last test, and you just said, oh, I moved the decimal place. And you moved the decimal place the wrong direction, one thing and another. I teach you to do conversions like this every time for this reason. I want you to get used to thinking about what is actually going on. Okay? So a few of you got the wrong answer on the test because you just moved the decimal place the wrong way. And you're not supposed to be moving decimal places. In this class, you're supposed to be writing conversions. Yes, ma'am?
Is it okay if we just put that equality statement? Or
This equality statement?
yes.
And you didn't do the math? So you wrote this equality statement, but you didn't do the conversion. You didn't do the dimensional analysis. Is that what you're saying?
I mean,
Well, I'm asking you. I don't know.
everybody knows that grams and grams is important.
Apparently not. Well, if everybody knew it, then everybody should have gotten it right on the test, right?
Doesn't mean we're going to get points for it, though.
Hey, Misha, I'm asking you a question. If everybody knows it, that's what you said. If everybody knows it, then everybody should have gotten that right on the test.
Yeah, Misha.
I mean, maybe you cut it out for them not doing the equality statement. I mean,
In this class, you're supposed to do the work. Show me all the work, all right? I'm from where? Missouri. You got to show me. Okay.
Wait, you're for real from Missouri?
No, God.
Ted, where are you born?
All right.
What is that? Mr. Ted?
Quiet.
Yeah!
All right. So since molality is moles of calcium chloride, please, folks, ladies and gentlemen,
I know.
Brian, you're the worst one. Please stop.
Brian, you're falling off the cliff right now.
Look, how many moles of calcium chloride did we calculate on Friday? From this calculation, how many moles did we get when we finished? 0.0. Another 0? 3 moles of calcium chloride. Okay. So on Friday we did this math and we got that many moles after we rounded off. And then on the bottom we're going to put 0.100 kilograms of H2O. And when we finish, we should get 0.033 moles per kilogram of calcium chloride in water. Okay? Now that is the same thing as, actually I can put an equal sign here, 0.033 mole CaCl2. Now here's the thing, guys, and this you must know this, you need to pay attention very closely. As long as your solvent is water, you don't have to include water in your concentration. Okay? You don't have to include water in the concentration, because if there's no listing of the solvent, then it's assumed to be water. If it's anything other than water, you'd have to say calcium chloride in something. Does everybody got that? You understand? Water's used so often, that we just leave it out when we're saying concentration if that's the solvent. But if it's not the solvent, you have to say what the solvent is, or your answer is incomplete. Okay, so now we got the molality. We put 0.033 mole calcium chloride over 1. Because by doing that, then, mole cancels. So it's 3 times 0.512 times 0.033 3 times 0.512. Sure. 0.033. And I got, let's see, 0.05068. Look, the only units I have left are degrees C. What am I trying to measure? A change in temperature. So I must have set it up right, because all I have left are the temperature changes. Okay? So that's degrees C, which I have to then round off. Okay, so I need how many digits in the final answer? 2. Okay, because we have 3 digits here. This one doesn't count. It's a counting number, and these leading zeros are not significant, so there's 2 significant digits. 1, 2 digits, underline, 0, well, let's use the black pen, 0.051 degrees C, and that's the change in temperature. All right, so if you took that typo and used that from the handout, 3 times 0.512 times, oh, no, 5, that's supposed to be 515, and then 0.033, you're going to get the same answer, 0.051. Okay. Now that's the change in temperature. Since the original temperature, the change in temperature is this, so you could add 100 to that. Now, so the final temperature, the temperature of boiling, is equal to the initial temperature. In this case, it's plus the change in temperature. Okay. So the initial temperature is 100.0 degrees C, plus the change in temperature, 0.051 degrees C. And really, by the time we round it off, it comes out to be, if I use that, 100 degrees C is really an absolute number. Okay, but I wouldn't count it wrong if you didn't do it that way. 100 degrees C is an absolute number. You can have as many zeros after the decimal as you want. 0 degrees C, the freezing point of water, is an absolute number. You can use as many zeros after the decimal as you want. Yes? Two zeros after the decimal place? You can. Or you can use 3 or 5 or 100.
So you can use all the zeros to make all the numbers.
Say again?
So you can use all the zeros to make like the other numbers.
Yeah, you really don't have to round off with this thing. I mean, you could, but you don't have to. It's like that zero continues. Okay, isn't that the symbol we use for continuing a number?
Yeah.
Okay. Yep. So we can say our final temperature is 100.051 degrees C. There's our final temperature for boiling. Okay. Yeah, like I said, you could.
You prefer.
I prefer you to, since we're going to assume 0 to be absolute and 100 to be absolute for the boiling and freezing temperature of
You
water.
got 100, Charlie. You got it right.
Okay. But now, if you rounded it off to, 100.05, I'll accept that. If you rounded off to 100.1, I'd accept that. Okay, for right now. But now that you know, from this point forward, I kind of expect you to know that 100 is considered an absolute and 0 is an absolute. Okay.